doing malware analysis. Hello, I'm Shabo, and I'm graduating next week. Currently, I don't have a job.
Howdy, I'm Logan. I'm graduating also in a week, and I have a job at Credera in Houston.
Howdy, I'm Philip Dang, graduating next week, hopefully, and I'm still doing interviews, so I do not have a job yet.
I'm Mishai. I graduate next week, and I've accepted the position at Caltech.
So our project is called BitBurrito. We did a machine learning-based Bitcoin price forecasting service. Some people have asked about the name, so on the first day of class we all decided that we like burritos, and our project is about Bitcoin, and we said that our financial models were rolled into one, so that's the story behind our name. So, like, why does what we do matter? Bitcoin, as well as other financial markets, is extremely, they're very volatile. And a lot of people don't really know much about Bitcoin or financial modeling in general. And so a lot of people, when they're trying to make financial decisions, try to consult tools, and so we thought that some of these models could be a helpful tool.
So the main purpose of BitBurrito, said specifically, is to design an aesthetically pleasing web app that illustrates regressions made by existing financial models for the purpose of allowing users to take more informed position when trading these Bitcoin futures.
So we had a couple ethical concerns in our project. The main one being that we wanted to make it clear to users that we were not telling them which position to take, like whether they should go long or short, because that would probably lead to their financial demise. So we just wanted to give them more information to help them make trades. Also, we're all taking ethics this semester, so we decided that our service was a technological artifact from an academic ethic perspective. And that means it doesn't have a moral value in itself, but it's an extension of the human will, and you can attribute moral relevance to it that way.
Yeah, so as a result of us creating this product, by its nature, it is multidisciplinary because not only do we have computer science and software engineering to create a web application, all the skills necessary to do that, but there's also a financial aspect to it, and the mathematics and the model generation in the back end. So not only does this project require it, but all of us have different backgrounds. Some of us have a strong math background, others have taken business classes in finance and have an understanding of the market to an extent. And also the people we interview, as we'll talk about later in our user studies and interviews, are also from a wide variety of backgrounds. We just didn't go to the computer science department and get interviewees and users. We asked our friends, family members, people that aren't in this major to see, what is your input, not just inside the world of computer science, but outside in all these different disciplines. So that was helpful and useful for us.
Just some briefing on if you're new to Bitcoin or financial models. The definition of Bitcoin is that it's a type of digital currency in which encryption techniques are used to regulate the generation of units of currency and verify the transfer of funds, and it operates independently of a central bank. As of December 8, 2016, one Bitcoin is valued at $772.16. And a fun fact is that it was worth less than a cent in 2009. Another key of Bitcoin is that it's extremely volatile, which means that it can raise up or go down at extremely unpredictable times.
So, continuing with what is Bitcoin, there's a significant cause of Bitcoin volatility just because it's newness to technology itself. There have been thousands of security experts proven that it's robust and reliable. And many businesses have started accepting Bitcoin, including Expedia and Dell and Overstock.
And what is financial modeling exactly? It is the building of abstract representations of real-world financial situations. They help perform financial calculations and make a financial recommendation.
So for our prior work, we did a pretty extensive study of existing financial modeling techniques, and most of them, at least the recent ones, use recurrent neural networks because they're good at modeling noisy time series data. But of course, financial time series is more chaotic than noisy, so they're not extremely successful, but they have a limited degree of success. And we originally intended to do this, but there were some complications, so we switched to different machine learning models instead.
And the main question is, how will our work be different than anyone else's? Right now, what's out there is usually there's just research papers on financial models. There's not really a web application, so our goal was to combine the two, combine the research, combine what we did, and put it into a nice user interface that someone can actually learn about Bitcoin or financial models if they don't know about it.
So these are our mentors. We got a lot of help with regards to finance in general, as well as machine learning. So they're a great asset to our team during this project.
So our design, as I mentioned earlier, we had interviews with people at the start of developing this project. You can see our initial design there, as beautiful as it is. It changed over time, getting feedback from people, how would you create something like this? What would you want a website like this or a web application like this to look like? I have some feedback quotes up there. More info on the main page. We implemented a lot of talk about this bottom section where you can select models and whatnot. And a lot of people like the design, the color scheme in the background. And then through all this iteration, we ended with our final design, which you'll see here and in the video at the end.
So how did we build BitBurrito? Our main front end was using Ruby on Rails that was hooked up to a Postgres database in the back end, where David would basically pull Bitcoin price data with using Python scripts, manipulate the data using our models, and then place them back in the Postgres database. From there, we were able to pull those models straight from the database and then modify them and display them using Google Charts onto the website. And most of our web services, we used Amazon. They were able to host both our front end and our back end. So the architecture in general, basically we pulled the Bitcoin API data, modeled it, placed it in the database, and then from the database pulled the Bitcoin models, ran our algorithms with Python, and then stored those values, price values back into the Postgres database. From there, we were able to display that on our front end using Google Charts API.
We also implemented a tutorial. We accepted the fact that some people that encounter our website aren't going to have much exposure to either Bitcoin or financial modeling, so we provided access to additional information. People landing here who don't know, what is a financial model, or what do these different financial models, as we'll describe in a second, even mean? What are their purpose, and how is this going to be useful for me? So we provided this specifically for that purpose.
So just to talk about a couple of our models that we used. One of them was a support vector machine regression. For those of you that don't know, a support vector machine takes an input and maps it to an arbitrarily high dimensional space and finds a maximum margin separating hyperplane. From then, regression can be performed on new data. So this is, in part of our experience, we ran a Python notebook. This is the Bitcoin price and the fit of the SVR model, as well as the prediction. We also did backtesting similar to this. So for 12 months, the past 12 months, we did a fit and then a prediction of with our models for the Bitcoin price. And coming back to the SVR, we see that this in the lower left, the green is November of 2015, and the red is the prediction for that month. And we found a couple interesting things in the backtest, namely that all our models seems to miss the big spike in July over here. We thought that was interesting because even though sometimes they were fairly accurate on some of the smaller market shifts, they missed the big one.
So as David said, we have used existing regression models from the Python standard libraries, which is for the machine learning and the data science. And we have been training this Bitcoin price data and show up in our own website. So in here, you guys can see the blue lines and the red lines, they are overlapped in the middles. And the blue line is the fit line, and the red line is predictions. So we made them string lines because it's easy for people to see. And also the orange line is here is actually the Bitcoin price. Okay. The next model here is decision tree models, and we took the example of the September 2016, and compared to the first models, we can see at the end, the orange lines, the price is approaching to the prediction lines. So we can see here, these two models the decision trees, it looks better to predict the Bitcoin price at the end of the September. Because there's so many uncertain factors to affect the Bitcoin price in stock market, so there isn't a best model to handle all these cases. But if the prediction price is the same or similar at same point in all of these models, so maybe the user can consider it is accurate, the price.
So reflecting back on our time at A&M, as all of us are moving on at this point, we thought about, okay, how did our education up to this point at least help us in building this application? And the obvious classes are the introductory and the intermediate computer science courses, giving us a fundamental understanding of programming languages, how software works, and especially on working on a software team, how to build a product together. And specifically, a few of us have taken this last course here, 431 Software Engineering, which specifically gave us good input and good education on the Rails framework, which, as Mishak mentioned, that's what we use, including interfacing with PostgreSQL, the database, and also introducing the agile development process to us.
So we had a couple items that we thought would make good future work. The first of which would be to add the RNNs back into our system, which we had previously abandoned. And the second of which would be to add other currencies and see how the relationship between other currencies and Bitcoin plays out, whether currency prices drive Bitcoin or Bitcoin plays a role in the price of the currencies themselves.
Our user studies were pretty straightforward, as I mentioned earlier. Started with users showing the BitBurrito chart from the website, frozen at the data of October 1st, just for consistency's sake, so that every user sees the same data, even if they came in on different days. Second, they were asked to predict what they thought, just of how the graph looked, if the next day Bitcoin price would go up or down. Then they were shown our next day predictions generated by our models, and they either changed or kept their predictions. And then the actual next day Bitcoin price was revealed to them, and users were asked the following questions, which is visualized here. First question, how did interacting with BitBurrito affect your financial decision on the data 10-1? 95% of users either said it changed their decision or affirmed their decision. One user said it had no effect. 95% of users here said that, and this is directly in line with our statement of purpose. Did BitBurrito help you make a better informed position on Bitcoin futures? And one user said no. So those are our results. Reflecting on this and our purpose and our definition of success, our definition of success is lined up with our statement of purpose, which is allowing users to take more informed positions when trading Bitcoin futures. So based on this data and user study data, we believe that Bitcoin did achieve success and exceeded expectations. So I have a video to show you of our site.
So here you can see how the user can change the different dates and be able to decrease the range of where they wanted to see the dates. This one just displays the Bitcoin data. Here we see the SVR model. Users can go through and scan, red being the prediction line and blue being the fit line for the Bitcoin price.
I'm going to pause real fast. It's also kind of unclear. We've got a lot of feedback during the class that the prediction, even though it's a solid line across the screen, is actually for the price right at the edge. We just thought that the solid line would help visibility, but it's not exactly clear. And just like a single dot at the end is also not very obvious. So perhaps there's a better way to do that.
So they can change the dates and see the respective time. Also, other parts of the website include the tutorial page on the main page, as well as this about and a contact page with our
Any questions?
How scalable this model is in terms of transactions or entries?
Performance is pretty quick, especially since when we did our back testing, when we trained the model for that, we sparsified it by dropping a random subset of rows, and we only trained on a subset of the data points in each month. which we found didn't really affect the performance, but significantly reduced the amount of training time required.
Yeah.
So our initial goal was to have a new model created every day, and then we thought we could also probably do twice daily. And that's definitely achievable with the training rates and the time that we were seeing during our investigation.
You talked about how the application affected the user's confidence in their prediction. How were their predictions really? Did they mostly predict the up or down, or was it a coin flip?
It was, I mean, most of the users, it was either or, it was about 50-50. I mean, a lot of them could see the graph and kind of see where it was going, but based on their own knowledge and what they had seen so far, there really wasn't much.
So they were more confident, but they weren't necessarily more accurate.
That's correct.
Okay.
We said that if we were accurate, we would not be here today. We would
Right.
be off in 10 years.
Yeah.
You'd have already left.
So, to predict, for the prediction, what are the regressors that you use in the model?
The regressors used?
Yeah.
We used K-nearest neighbors regressor. Oh, that's we used a decision tree, KNN, multi-layer perceptron.
Those are the algorithms.
Those are the algorithms.
But I'm talking about the regressors, like you must be using some data points as inputs to predict.
So we just use price and time. We didn't do any
The
extra.
historical price?
Bitcoin price.
The historical Bitcoin price is what you use?
Correct.
Only that one thing?
Yes.
Did you consider bringing other factors in? I think
We-
you had mentioned some things.
We did consider it. Some approaches have tried to do like natural language processing on news articles, or even tie in like data from other markets and like the S&P 500 index. But we didn't really see like the need for that in this initial phase. It would perhaps make a good future work investigation, but research has shown that that doesn't make a huge difference on the accuracy of these models, especially given the nature of the systems that you're trying to predict. It's difficult even with the extra information to
When you applied your models and you did your backcast, were you reasonably in alignment with the when you did your testing? Were you reasonably in alignment?
Yeah, we were actually
It was just historical price trend.
reasonably pleased with the way the backtesting went, but then there were some months that were very off. So like the red is our prediction, and see this month we missed, this month we were pretty close, this month we were close, and then this month we were totally off. We were in the wrong direction. Significantly here, but so it's pretty interesting, and all the other models were similar, especially for July.
So you mentioned in your presentation that you couldn't predict a big spike.
All right.
Did you just say, hey, we can predict it and move on, or what did you do when you saw that? How did you interpret that?
So yeah, we didn't do anything about that. And if you were actually trading on this and you took a short position that month, you would have lost a lot of money. So it's a difficult problem to solve. That's for sure.
So, so to the point earlier, was there any curiosity as to what was happening at that time? You know, whatever that timestamp looks like, as to what might have influenced that price?
Okay, so I think I understand your question. And Bitcoin is notorious for having like bubbles or spikes like this. It's just incredibly volatile, and so I don't know exactly what drove this. We didn't look at news articles or anything around this time. But I think it was just volatility that our model had not been trained on. So
Why'd you pick Bitcoin versus the peso?
Bitcoin data is really easy to get. So a lot of like stock data you have to pay for if you want high quality data, whereas Bitcoin, the exchange history is all free and open source.
It's open to the public.
I have a question. Can you elaborate on some of the machine learning techniques that y'all use?
How so? What would you like to hear?
Like, I mean, for the models, did you go back, did you use machine learning to like, improve the models, or was it kind of like a one-time run?
So the models were trained individually on each month. We didn't like do some sort of like updated training as we went. Yeah.
So you said, for example, SVR, support vector machines, right? So obviously the concept is to project the data to a higher dimension and then calculate the distance, right?
Right.
So here, as from what you said, there is only one dimension, which is the previous Bitcoin price itself.
Mhm.
So I don't understand really how you basically, how efficient the SVM here is here. I mean, for
Right.
example, right, like if you're taking like where the Dow Jones ended up yesterday as one factor,
All right.
and how the oil price has been, taking that as another data point or another feature. So if you have features like that, each feature becomes one dimension,
All right.
right? So here in this case, we're talking about just only one dimension.
So in this case, instead of using multiple dimensions like different data sources and having those be our dimensions in SVR, we used each data point at each point in time was considered a dimension. That's how we ran this model.
And how long back you are going into the past to predict?
1 month. So we used the most recent one.
I think my understanding of how you use these models is not quite same as what you use. I mean, obviously, if you are using historical Bitcoin price, that becomes just one dimension. You will have 30 vectors, 30 features, feature sets, one for each day. But I don't think each day's price becomes one dimension.
Okay, I can double check in our software. Any other questions?
So I saw that you were using AWS. Just curious as why, did you guys explore any of AWS's machine learning platforms?
We looked at that, and they actually
use-
came out with a lot of new stuff with regards to machine learning lately that we were pretty excited about, but we didn't really mess with it. We're pretty comfortable with sklearn, so we just went with that. Thanks a lot.
Thank you.